Hello everyone, this is Professor He. Nice to see you again. The topic of this task is about the Carnot principles. The second law of thermodynamics puts limits on the operation of cyclic devices as expressed by the Kelvin, Planck, and Clausius statements. A heat engine cannot operate by exchanging heat with a single reservoir, and a refrigerator cannot operate without a net energy input from an external source. We can draw valuable conclusions from these statements. Two conclusions pertain to the thermal efficiency of reversible and irreversible heat engines, and they are known as the Carnot principles, expressed as 1. The efficiency of an irreversible heat engine is always less than the efficiency of a reversible one operating between the same two reservoirs. 2. The efficiencies of all reversible heat engines operating between the same two reservoirs are the same. These two statements can be proved by demonstrating that the violation of either statement results in the violation of the second law of thermodynamics. The topic of this subtask is about the proof of Carnot principles. Suppose a heat engine works between a high-temperature reservoir and a low-temperature reservoir. Each time the heat engine completes a cycle, it absorbs heat from the high-temperature reservoir, part of which is converted into mechanical work, and the remaining part is discharged to the low-temperature reservoir. From the definition, we have thermal efficiency of heat engine cycle. When the heat engine completes a cycle, the working fluid returns to its original state. The entropy change of the isolated system is. Therefore, the efficiency of the heat engine cycle is. This is the Carnot principles. The topic of this subtask is about the summary of Carnot principles. 1. Any reversible heat engine working between two reservoirs, the efficiency is the Carnot efficiency operating between the temperature limits. 2. Any reversible heat engine working between multiple reservoirs, the efficiency is less than that of the Carnot efficiency operating between the temperature limits. 3. Any reversible heat engine working between multiple reservoirs, the efficiency is same as that of the reversible heat engine operating between the temperature limits. Therefore, all heat engines working within a given temperature limit, the highest or maximum heat engine efficiency limit is the Carnot efficiency. An actual heat engine cannot reach this maximum theoretical efficiency value because it is impossible to completely eliminate all the irreversibilities associated with the actual cycle. Carnot principles reveal 1. Any cycle configuration requires at least 2 thermal reservoirs with different temperatures. 2. Carnot principle points out the limit value of thermal efficiency, which is only related to the temperatures of heat source and cold source. 3. The fundamental way to improve the thermal efficiency is to increase the temperature of the heat source, reduce the temperature of the cold source, and reduce the irreversibility factors as much as possible. Carnot principles theoretically determine the conditions for the thermal energy conversion to the mechanical energy through a heat engine cycle, and point out the ways of improving the thermal efficiency of the heat engine. Carnot principles are of great significance to the establishment of the second law. Okay, that's all for this task. Thank you very much, and see you next time.